Hello everyone. I'm going to walk you through my Unit 5 PowerPoint. This is on bonding, ionic and covalent. In this unit we will be talking about how to draw Lewis structures, types of bonding, the shapes of molecules, and then intermolecular forces. So the first thing you need to know how to do before we can talk about bonding is you need to know how to draw a Lewis structure. This is going to be based on the number of valence electrons that an element has, so don't forget that that is based on the group number. So as you begin this section of the notes, you need to have a periodic table handy, preferably the one we colored and made notes on, so you can remember how many valence electron an element has. So the reason we draw Lewis dot structures is we are trying to visualize bonding. And the valence electrons, or the outermost electrons, are the electrons that take part in bonding. And that's because they are the first to come into contact with other atoms. So remember, some elements are more stable by losing electrons, some are more stable by gaining, and some prefer to share electrons. And the electrons being lost, gained, or shared, those are valence electrons. So what you're going to do is take the element symbol. You're going to pretend like there's a box around that symbol, and you need to put a valence electron on each side of the box before you pair any of them up. So I'm going to show you some examples of that. For oxygen has 6 valence electrons, so we put one dot on each side of oxygen before we pair those up. And what you need to see is that oxygen can form 2 bonds, but it also has 2 lone pairs. And I'll talk about that in a minute when I pull up my document camera. For magnesium has 2 valence electrons, so you put one on 2 of the sides of magnesium. Now I want you to go ahead and practice these next 4 examples on your own, and I'm going to switch over to the document camera to show those to you. Okay, so back to our example of oxygen. I'm not going to actually draw the box. Remember, it's meant to be an imaginary box, but I am going to show you oxygen has 6 valence electrons, so we put one dot on each side of oxygen before we pair them up. So what you need to see now is that this is considered to be a lone pair. That's a pair of electrons that is not going to bond because it's already paired up. It's already stable. Now those are electrons that are not paired up, so that's where bonds will form. So we would say that oxygen has 2 lone pairs, and it can form 2 bonds. Now magnesium has 2 valence electrons, so we're going to put one on 2 of the sides of magnesium. You can see that magnesium has 0 lone pairs, but it has 2 spots available for bonding, one here and one here. Bromine has 7 valence electrons, so 1, 2, 3, 4, 5, 6, 7. So you can see that bromine has 3 lone pairs, and it has 1 spot available for bonding, so it can form 1 bond. Lead is in group 4, so it has 4 valence electrons. None of those are paired up, so that's 0 lone pairs, and it can form a total of 4 bonds. Cesium is in group 1, so it has 1 valence electron, so it has 0 lone pairs, and it can form 1 bond. And then nitrogen is in group 5, so it has 5 valence electrons. So it has 1 lone pair and 3 spots for bonds. All right, now we're going to talk about bonding. So there are two types of bonding we're going to focus on, and that is ionic and covalent bonding. Now, ionic bonding is going to occur between metals and nonmetals. As you remember, hopefully from Unit 4, metals tend to lose electrons to be stable, and nonmetals tend to gain electrons to be stable. So when an ionic bond forms, a metal loses its electrons to the nonmetal. Now the metal is positive, the nonmetal is negative, and they are held together by opposite attractions. Those positive and negative forces attract each other, and that's what forms the ionic bond. So one atom will gain, the other will lose. This results in opposite charges. So this is how salt forms. Sodium, hopefully you remember, and you should have a periodic table nearby. You need to look at sodium. Sodium is in group 1. It has one valence electron, and it loses that one valence electron to become stable. Chlorine is the opposite. Chlorine needs to gain one valence electron to become stable. So when salt forms, sodium loses an electron, chlorine gains. Sodium is now positively charged, chlorine is negatively charged, and they form an ionic bond. And you can see that they arrange themselves in such a way that all of the positives are completely surrounded by negatives on 6 sides. All of the negatives are completely surrounded by positives on 6 sides. And this creates a crystal lattice structure. That's why if you were to take a microscope and look at a grain of salt underneath it, it would look like a cube. That is the shape that those ions form. So I'm going to flip back over to my document camera and show you how you draw Lewis structures to represent ionic bonding. All right, just to give you a visual representation of what I just discussed. Sodium has one valence electron, so we're going to draw one dot. Chlorine has 7 valence electrons, so we're going to draw 7 dots. And sodium is going to lose that one electron to chlorine, and that electron is going to go in the spot where chlorine has an available place for bonding. Because remember, these electrons don't take place in bonding. Those are lone pairs. This is the spot where this electron is going to want to pair up. So that makes sodium positive, chlorine's negative, and the formula would be sodium chloride. To give you another example, if we were to bond calcium and bromine, calcium has 2 valence electrons, bromine has 7. So you can see that calcium needs to lose 2 electrons. Well, bromine can only accept one of those electrons. So you're going to have to draw another bromine. And that's where calcium's other electron will go. So once calcium loses 2 electrons, it has a positive 2 charge. Each bromine will have a negative 1 charge after they gain an electron. And when you write the formula, it's going to be CaBr2. And that little 2 represents the 2 bromines that have bonded with calcium. You should notice that for ionic compounds, the charges always cancel out. So with sodium chloride, it was positive 1, negative 1. For calcium bromide, it's positive 2, negative 2. So that's always a good thing to check for, is whether or not our charges are canceling out. All right, I want you to try these next 3 examples on your own. Using Lewis dot structures, I want you to draw how each of these pairs of metals and nonmetals would bond together. All right, so potassium has 1 valence electron. Sulfur has 6 valence electrons. Remember, we're figuring this out based on what group these elements are in. So if you're like, how does she know how many dots to put around it? You need to be looking at your periodic table and looking at what group these are in. So potassium is going to lose that 1 electron to sulfur, and now potassium has a +1 charge. Potassium is stable, but sulfur is not. You still need one more potassium atom to bond with sulfur in this spot. So now both of your potassiums have a +1 charge. Sulfur just gained 2 electrons, so it has a -2 charge. And your formula is going to be K2S. For calcium, it has 2 valence electrons. Oxygen has 6. Calcium can lose both of its electrons to oxygen. So now calcium has a +2 charge, oxygen is -2, and the formula would be CaO. Notice that the charges cancel out, +2, -2. For our last example, you have aluminum with 3 valence electrons, and you have oxygen with 6. So aluminum can lose 2 of its electrons to oxygen, and now this oxygen is stable, but aluminum still needs to lose 1 more. So we're going to draw another oxygen. So now aluminum can lose 1 of its electrons to oxygen, and now aluminum is stable, but oxygen is still not stable. It needs to gain 1 more. So we're going to draw aluminum again. And now aluminum is going to lose 1 of its electrons to oxygen. Now this oxygen is stable, and you might be thinking, is this ever going to end? But we're almost done. Aluminum still needs to lose 2 electrons, so all you need to draw is 1 more oxygen. And aluminum can lose both of its electrons to that last oxygen. And that means each of your aluminums is +3, and each of your oxygens is -2. So you have a +6 and a -6 charge. And your formula would be Al2O3. 2 aluminums and 3 oxygens.